What was there before the Big Bang? It's a question that has baffled scientists and philosophers for centuries, pushing the very limits of what we can comprehend about our universe. The standard model of cosmology tells us that approximately 13.8 billion years ago, everything we know, all matter, energy, space, and time, erupted from an infinitesimally small, hot, and dense point called a singularity. But this explanation, as profound as it is, leaves a gaping void in our understanding. It describes the how of our universe's beginning but remains silent on the what came before. To ask about a time before the Big Bang is in itself a paradox, as time itself is believed to have begun with the singularity. It's like asking what's north of the North Pole. The concept simply breaks down at that extreme point. Yet, the human mind is endlessly curious, and physicists are not ones to shy away from a challenge, no matter how monumental. They have crafted several compelling, albeit speculative, theories that attempt to peer beyond the veil of our cosmic dawn. These ideas are not just wild guesses, they are born from the intricate mathematics of general relativity and quantum mechanics, our two most successful descriptions of the universe. While we may never have a definitive, observable answer, these theories offer fascinating glimpses into what could have preceded our existence. They challenge our fundamental assumptions about reality, time, and the very nature of a beginning. One of the most intriguing and elegant ideas is the Big Bounce. This theory proposes that our universe is part of an eternal cycle of expansion and contraction. It suggests that the Big Bang was not a beginning from nothing, but rather the rebound from a previous, collapsing universe. Imagine a universe that, after expanding for trillions of years, eventually succumbs to the pull of its own gravity. The expansion slows, halts, and then reverses, leading to a big crunch. Everything in the cosmos would hurl back together, converging into an incredibly dense state, reminiscent of the initial singularity. However, in the Big Bounce model, this is not the end. When the collapsing universe reaches a point of maximum density, a new, powerful repulsive force, perhaps governed by quantum gravity, takes over. This force would trigger a massive rebound, an explosive expansion that we perceive as the Big Bang, giving birth to a new universe. This cycle of crunch and bounce could be endless, meaning our universe is just one in an infinite chain of universes, each born from the ashes of its predecessor. The Big Bounce elegantly sidesteps the problem of a singular beginning, replacing it with an eternal, oscillating cosmos. It suggests that the fundamental laws of physics are preserved from one cycle to the next, with each universe inheriting properties from the one before it. This concept paints a picture of a universe that is both created and eternal, constantly renewing itself. It's a powerful idea that transforms the Big Bang from a one-time, unique event into a recurring phase in the life of a much grander, cyclical reality. Another captivating theory comes from the brilliant mind of Sir Roger Penrose, a Nobel laureate who worked closely with Stephen Hawking. His idea is called Conformal Cyclic Cosmology, or CCC. Like the Big Bounce, CCC also envisions a cyclical universe, but its mechanism is vastly different and, in some ways, even more mind-bending. Penrose suggests that our universe will continue to expand indefinitely. Over unimaginable timescales, trillions upon trillions of years, all the stars will burn out, galaxies will drift apart, and even black holes will eventually evaporate through a process known as Hawking radiation. The universe will become a cold, dark, and empty place, filled with only a diffuse bath of photons and other massless particles. At this point, the universe will have lost all sense of scale. Without massive particles to provide a reference for size or time, the concepts of space and duration become meaningless. According to Penrose, at this end of time, the infinitely large and empty universe of the far future becomes mathematically equivalent to the infinitely small and dense state of the Big Bang. In this strange, scale-invariant state, the vast, cold emptiness of the old universe smoothly transforms and becomes the hot, dense beginning of a new one. This new cosmic epoch, or aeon as Penrose calls it, begins with its own Big Bang, unaware of the universe that preceded it. Each aeon is a self-contained universe, but it carries faint traces from the one before. Penrose even speculates that we might be able to detect these traces, like faint temperature rings in the cosmic microwave background, the leftover radiation from our own Big Bang. These Hawking points, as he calls them, would be the remnants of supermassive black holes from the previous aeon, their energy bleeding through into our own. Finding such evidence would be a monumental discovery, providing the first tangible link to a universe that existed before our own. Then there is the profound and rather unsettling possibility that the question itself is flawed. What if there was no before? This isn't just a philosophical dodge, it's a conclusion that arises directly from Einstein's theory of general relativity. According to this framework, space and time are not separate, static backdrops for events to unfold upon. Instead, they are interwoven into a single, dynamic fabric called spacetime. This fabric can be warped, bent, stretched, and compressed by mass and energy. The Big Bang theory suggests that the entire universe, including spacetime itself, originated from the singularity. If time began at the Big Bang, then asking what happened before it is logically incoherent. It's like trying to find a point on the Earth's surface south of the South Pole. The concept doesn't apply at that boundary. Stephen Hawking was a prominent advocate for this perspective. He described it using the analogy of a cone. The point of the cone represents the Big Bang, the singularity where space-time curvature becomes infinite. As you move away from the point, the cone expands, representing the expansion of the universe. In this model, there is no space or time at the tip of the cone itself. Time emerges as a dimension only as you move away from that initial point. Therefore, the universe has a beginning in time, but time itself has no beginning. It simply exists as a property of the universe, and without the universe, the concept of time has no meaning. This idea, known as the no-boundary proposal, suggests that the universe is completely self-contained. It doesn't require an external cause or a preceding state to bring it into existence. It simply is. While this might feel intellectually unsatisfying, it is a logically consistent outcome of our best theory of gravity. It forces us to rethink our intuitive understanding of cause and effect, which is deeply rooted in our experience of linear time. In the quantum realm of the universe's origin, such familiar rules may not apply. These theories, the Big Bounce, Conformal Cyclic Cosmology, and the no-boundary proposal, represent the forefront of cosmological thought. They are attempts to answer the ultimate question using the tools of mathematics and physics. Each one paints a vastly different picture of our cosmic origins. Are we part of an endless cycle of birth, death, and rebirth? Are we just one aeon in an infinite succession, with faint echoes of a past universe hidden in our sky? Or did our universe, along with time itself, spring into existence from a state of nothingness, requiring no prior cause? For now, these questions remain unanswered. Our current technology and understanding of physics are not yet advanced enough to definitively prove or disprove any of these ideas. To truly solve this mystery, we would likely need a complete theory of quantum gravity, a theory of everything that successfully unifies Einstein's general relativity with the strange rules of quantum mechanics. This is the holy grail of modern physics. Such a theory would allow us to describe the conditions within the singularity itself, a place where our current laws break down. It might finally tell us whether the Big Bang was a true beginning or just a transition in a much larger, more ancient cosmic drama. The quest to understand what came before the Big Bang is more than just a scientific endeavor, it's a reflection of our innate desire to understand our place in the cosmos. It's a journey that takes us to the very edge of knowledge and imagination. While we wait for the next breakthrough, we can marvel at the ingenuity of the human mind and the incredible possibilities these theories present. The universe is under no obligation to make sense to us, but that will never stop us from trying to understand its deepest secrets. Thank you for joining us on this journey to the edge of time. If you find these cosmic mysteries as fascinating as we do, be sure to subscribe to Space Repo for more explorations into the wonders of our universe.